Okay, this is the 3.4 extra examples from what we did in class. So these are the ones that are similar to what we did in class, but we skipped over them because we wanted to hit the highlights. So the directions here are we're going to do f of a, f of negative a, negative f of a plus h, f of a plus f of h, and then the difference quotient, which I'll probably have to do a little bit of space for that one, f of a plus h minus f of a over h. Okay, so let's do f of a first. That just means you take your function and you change all the x's to a's. So there would be the answer for that one because our function is 3 minus 4x. This one says change them to negative a's. So this would be 3 minus 4 times negative a. That actually changes that to now a plus 4a. This says multiply the whole function by negative 1. So take your f of a and multiply it by negative 1. That will give you negative 3 plus 4a. F of a plus h means that we want to do a binomial where there used to be a monomial. So we think about that like this, where the a used to be. And that needs to get distributed. So that would be minus 4a minus 4h. 3 minus all of that. And then this one says do two separate things. Do f of a and then f of h and add them together. So that would be 3 minus 4a plus 3 minus 4h, like terms of 3. So that would be 6 minus 4a minus 4h. And then this final one, I'm going to write it down here, actually give myself a little bit of room. This has already been done essentially. We did f of a plus h. That's this answer. Let's just bring that down. We did negative f of a, which was this one. So negative 3 plus 4a. Divide all of that by h. If you've done this correctly, some things should cancel out. So this is just negative 4h over h, or negative 4. Okay, we need to do the same thing for part C. I'm going to give myself a little bit more space this time. So we need to do f of a. This time we do have a harder problem though because we have an x squared and an x. F of a would just be 2a squared plus 3a minus 7. F of negative a will require a little bit of work. We need to plug in a negative a and then work out any signs. So notice it's going in wherever the x used to be. That's supposed to be a minus 7. A squared, negative a times negative a is still positive a, so that would be 2a squared. Negative times positive here, though, would make that a negative 3a and then minus 7, so it did change the sign in the middle. Then we would want to do negative f of a, which is negative 1 times your original function with an a plugged in. So that makes that negative 2a squared minus 3a plus 7. Then we want to do f of a plus h. This one is tricky here. We have to plug it in for a part that is going to be squared and for a part that is not squared. Notice that the a plus h goes wherever there used to be an x. So when you work this out, I'm going to give myself some more room. When you work this one out, you're going to have to FOIL this first part. This is 2 times a plus h times a plus h. I can go ahead and distribute this. This is 3a plus 3h minus 7. I need to FOIL out the a plus h's. That's a squared, ah, and another ah, so that would be 2 ah's in the middle. And h times h is h squared. Bring everything else down. Distribute this 2. And notice nothing is like terms. Everything has different powers on the different variables, so you cannot add any of the terms together. And then we're supposed to do f of a plus f of h. That would be f of a is 2a squared minus, no, excuse me, plus 3a minus 7. And then plus, then we would do the same thing but with h's. So 2h squared plus 3h minus 7. The only thing we can combine is the negative 7's. So 2a squared plus 3a plus 2h squared plus 3h minus 14. And then for our final one, we need to do the f of a plus h on top, remember, because that's the difference quotient. And I am running out of places I can write that, so let's do it over here at the top. So this last one is, I need that in red, the f of a plus h minus the f of a over h. F of a plus h was this long thing right here, so that's 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 7. Negative f of a is this guy right here, so that's also on top, negative 2a squared minus 3a plus 7. All of that, since I had to stack it, sorry, is over h. I have 2a squareds that are canceling, 3a's that are canceling, and 7's that are canceling. So I'm left with a 4ah plus a 2h squared plus a 3h all over h. And that reduces down because everything is divisible by h. So I get 4a plus 2h plus 3. And that would be my final answer for that one. Okay, so then we need to skip down because we did some of these in class. I skipped E in class, so we need to talk about that. The directions for this one were find the domain of the function. E has two problems. It has a square root in it, and so that makes it a radical situation, and it also has things in the denominator. I'm going to go ahead and take care of the thing in the denominator. X cannot equal, minus 3 cannot equal 0, so X cannot equal 3. For this part, normally X plus 3 would be greater than or equal to 0, but since the radical is in the denominator, we don't let it be equal to 0. So X is greater than negative 3. If you think about those two on the number line, here's negative 3, parentheses, shade to the right, but positive 3 is over here, so that means we actually need to make an open circle because we have a value on this right side, oops, that is not going to work because it's in the denominator. So essentially, we shade everything bigger than negative 3 except for 3. In interval notation, that would be negative 3 to 3, both with a parentheses, union with 3 to infinity. Okay, other things from this packet. I wanted to graph some more of these functions. Some of them we did, and others I said I would do on the video. This one, this would be positive 3 since it's a linear equation. It's mx plus b. And the slope is negative 2 over 1, so that's down to right 1. So you can draw the graph from there. It says, after you've done that, tell us the domain and the range. Well, this uses every x in the number line. You can plug any x you want into a polynomial. So this would be negative infinity to infinity. And this arrow means this goes as far down as we want or as far up as we got. So the range would also be negative infinity to infinity. This graph is constantly decreasing. It is never going to increase. It's never going to stay flat or constant. So this is always decreasing. So this would be decreasing on its entire domain. We already did B in class, so let's look at some other ones. Let's do C. Okay, for C, to graph this one, you first of all need to know where it's going to start. So I'm going to go ahead and find my domain first. So for the domain, we set the part and the radical greater than or equal to 0 since this is a square root. We would subtract over the, it'd be negative 4, then we divide by a negative, which means that flips this. So my domain is actually less than or equal to 4. So this would be 4 and then maybe 3, 2, 1. We'll see how many of these give us nice numbers. So by the way, domain would be negative infinity to 4. We have to get our graph to see our range. So let's graph this. 4 minus 4 is 0. Square root of 0 is 0. 4 minus 3 is 1. Square root of 1 would just be 1. 4 minus 2 is square root of 2. I don't really want to graph that. And 4 minus 1 would be square root of 3. Maybe I'll get one more point. Let's plug in 0. 4 minus 0 is 4. Square root of 4 is 2. So 4, 0, 3, 1, and 0, 2. Remember, square root functions kind of like parabolas that are on their side. This one is going, it's being done in the opposite direction. Normally that would be a transformation across the y-axis from what it originally would look like. And let's see, the domain we got is 4 to negative infinity, so we wrote that. This has a range of it is either 0 or bigger because we never go into the negative y values, but this is continually getting wider even though it takes a long time. And this one is also decreasing, but it's decreasing on its domain, so negative infinity to 4. So there are the things that they wanted. Okay, f of x equals 3, kind of not really a trick question, but just making sure you understand that this is just y equals 3. So this one's not very interesting, it's just a horizontal line. So a horizontal line at 3. So its domain is negative infinity to infinity. Every x shows up somewhere, but its range is a single value. It has a single height of 3. So we put that in set braces. And then this one is always constant, so it would be constant forever on its domain. So there are those pieces. Okay, and I omitted this one because it's harder than anything we would ever do in a test. I wanted to do one more difference quotient. This is the one that looks more like what you might see on the test. So instead of using the a plus h on the test, we actually use x plus h and negative f of x. You do this problem exactly the same. So here's the formula. It's always given to you in the directions of the problem. So we need to do f of x plus h, and we also need to find negative f of x so that we can plug them into our numerator. So negative 2 times x plus h in for the whole thing where that x used to be, and then plus 3 at the end. We need to FOIL this since it's being squared. So that would be negative 2 x squared plus xh, another xh would be 2 xh's plus h squared plus 3, and we would then distribute that negative 2. So it's negative 2 x squared minus 4xh minus 2h squared plus 3. That's going to be f of x plus h. Negative f of x just means you take this function and you change all the signs. So that'd be positive 2x squared minus 3. You take both of those parts and that is your numerator for your difference quotient. And then remember we're going to put that all over h. So negative 2x squared minus 4xh minus 2h squared plus 3, and then plus 2x squared minus 3 because we've already distributed that negative all over h. My 2x squareds are gone, my 3's are gone, so I get negative 4xh minus 2h squared over h. Everything is divisible by h. So my final answer is negative 4x minus 2h. Okay, and then the last one is if you see something like this and it says it's a linear function, essentially they've just given you two ordered pairs. Remember, if this is a function notation, this is x, and the number on the other side is y. So this is the ordered pair negative 2, 7, and 4, negative 2. So we can find the slope by doing negative 2 minus 7 over 4 minus negative 2. That's negative 9 over 6, which is negative 3 halves. We would then use one of the points, so either one. Maybe I'll do the 4 and the negative 2. So y minus negative 2 would be y plus 2. Then I have negative 3 halves x minus 4. Multiply the 2 to the other side, and then distribute the -3. So I multiplied 2 on both sides. And then get this in slope-intercept because we do want it to be f of x equals mx plus b. That we're calling it a linear function. So I need to subtract the 4 over and then divide everything by 2. And then instead of writing y, we write f of x for the y. So that'd be -3/2 x plus 4. And that completes the 3.4 extra examples.